Hello students, today we will study the topic Legendre transformation. So it is the mathematical process used to change the basis from one set to other. It is called Legendre transformation. Suppose one set is qk dot nt. If we transform this set to qk, pk and t, so this mathematical procedure is known as Legendre transformation. We know that the Lagrangian is the function of qk dot nt and Hamiltonian is the function of qk, pk and t. If we transform Lagrangian to Hamiltonian, means we have to go from this set to that set. Okay, so this procedure we have to apply. Okay, that procedure is known as Legendre transformation. Okay, now we will see the Legendre dual transformation equations. Suppose f be the function of two independent variables x and y, so f can be written as f is equal to fxy. If we differentiate this equation, we will get df is equal to del f by del x into dx plus del f by del y into dy. Okay, first we have to partially differentiate f with respect to x, del f by del x into dx, plus partially differentiate x with respect to y, del f by del y into dy. Okay, now we'll consider del f by del x is as u and del f by del y as v. So we'll get df is equal to u dx plus v dy, since u is equal to del f by del x and v is equal to del f by del y. Okay, so if we transform the function x f to f dash, okay, if we transform the basis from xy to independent variable uy, okay, if we say we change the set of basis xy to independent variables ui, then the differential quantity of this independent variable ui will be du and dy. Okay, so let there be another new function, that function f, which is the function of u and y, such that f dash can be related with the f by this equation, f dash is equal to f minus ux. So we will relate this f and f dash by this equation, and f dash is a new function which is the function of u and y, and u and y differentiation can be expressed as du and dy. Okay, now differentiate above equation, you will get df dash is equal to df. Here is the product rule of derivative u dx minus x du. Okay, x du. So we know that df from equation number 1. Okay, this is the equation number 1. We know that df is equal to u dx plus v dy. So replace this f by u dx plus v dy. So here plus u dx and minus u dx they will become 0. So df dash is equal to v dy minus x du. Suppose this is equation number 2. Now we have already considered that f dash is the function of u and y. Okay, so since f dash is the function of u and y, f dash can be written as f dash is equal to f u and y. F dash is the function of u and y. If we differentiate this equation, we will get df dash is equal to del f by del u into du plus del f by del y into dy. So suppose this is equation number 3. So in equation number 3 we got df dash is equal to del f by del u into du plus del f by del y into dy. Similarly, from equation number 2 we got df dash is equal to v dy minus x du. So we will compare this equation number 2 and equation number 3. So comparing equation number 2 and equation number 3, so we will get del f by del u, that is nothing but x. Okay, so here see that, so del f by del u, the coefficient of du is minus x here, and here the coefficient of du is del f by del u. So del f by del u is equal to minus x. Okay, it means that x is equal to minus del f by del u. Here the coefficient of dy is del f by del y. So del f by del y, and there the coefficient of dy is v. So we will get v is equal to del f by del y. So by comparing equation 2 and 3, we will get these equations. And also we have u is equal to del f by del x, that we have already considered in our this slide, u is equal to del f by del x. So these three equation, okay, these three equation, that is x equal to minus del f by del u, v is equal to del f by del y, and u is equal to del f by del x. So these three equations are known as Legendre dual transformation equation. Okay, so we have seen what is Legendre transformation, then we have come up with the Legendre dual transformation equations. Now we will see why Legendre dual transformation equations are important, or what are the advantages of Legendre dual transformations. The advantages are, it is used to determine how energy function for different sets are related, matlab two different set for two different sets, okay, how the energy functions are related. And it is used to transform from Lagrangian system to Hamiltonian system, that I have already told you in the first slide. Okay, it is used to transform from Lagrangian system to Hamiltonian system. Third advantage is it gives the solution of differential equation of several variables. Okay, one more important is it is used to convert from one function of one set to another set. So these are the advantages or importance of Legendre dual transformation or Legendre dual transformation equations. Okay, so today we have seen what is Legendre dual transformation, what their equations and advantages. So that's all for today. Thank you very much.